A GCD problem here. And GCD, I'll write it like this: GCD, greatest common divisor, and I'll just do an example, just in the event you haven't seen this. The greatest common divisor, or the greatest common factor of two numbers, is the largest divisor that divides both of them. So for example, the greatest common divisor of 49 and 21 would be 7. And you can see why. 7 times 7 is 49. 3 times 7 is 21, so 7 would be the greatest common divisor, all right? So easy enough concept. We just call it the GCD. Sometimes you just see it in parentheses without the, without the GCD part. Now, what we have right here looks impossible, okay? We're supposed to find the greatest common divisor of 2024 terms. Let me write that down just to emphasize. 2024 terms. Okay, this is a year problem, but we start at 0 just because it makes the calculation slightly easier. Okay, but notice that from n equals 0 to 2023 is actually 2024 terms. Okay, so you first look at this and you go, what? Do I have to calculate all 2024, or there must be an easier way, right? All right, so there's 2024 terms here. Now, so yes, it would be almost impossible, and look how fast this grows to begin with. So not only would it be 2024 terms, but some of them would be unpronounceable numbers, probably hundreds of digits each, okay? So it turns out there's a better way to do this using what they call modular arithmetic. Now, again, the benefit of letting this thing be indexed by 0 is that b sub 0 just means you put a 0 everywhere you see an n. And of course, very well-known result, any base raised to the 0 power is equal to 1. And that's not just a convention, it can be proven. So anyway, a to the 0 is always equal to 1. All right, provided a is not equal to 0, I guess. Okay, so that should be a 0 right there. All right, so that's where this first term comes from. Now notice that that sums up to 33. And so already the first term, there's only 4 possible divisors of 33, namely 1, 3, 11, and 33, right? So the GCD has to be in that list, right? Because this is 1, b sub 0 is 1 of the 2024 terms. So you couldn't have a GCD of 66 because the G66 would not divide this, right? Okay. So already just by knowing the first term, we know the GCD has to be 1, 3, 11, or 33. All right, that's valid information. Okay, now, so what we do, we calculate the second term. This is actually the second term using the indices here. The 1 corresponds to the second term. This is just pure calculation using modular arithmetic. Now, this number already is a number very close to 1,000. It might be, I think, like 965. You can use what you call modular arithmetic to find out if it's divisible by 0 in a hurry. Notice that 12 is divisible by 3. 15 is divisible by 3. That makes it equal to 0 mod 3. Okay? And finally, right here, what do we have? 17 is 2. And 34 is congruent to 0. Let's see, wait a minute, sorry. 34 is congruent to 1, okay? 34 is congruent to 1. Let me write this down right down here, folks. 17 is congruent to 2. And of course, we're talking mod 3 here. And we're talking about mod 3 since it's a number in this list, right? So 17 is congruent to 2, okay? And again, mod 3, and also 34 is congruent to 1 since 3 times 11 is 33, right? So 34 is congruent to 1. Whoops, that is a 4, ladies and gentlemen. 34 is congruent to 1. Okay, so we know the first term is not divisible by 3, right? We know the first term is not divisible by 3. So that means we can rule out this 3 right here, right? That 3 is not a possibility, since 3 does not divide b sub 1. So the only possibilities is that all the numbers are relatively prime, which is very believable, or 11 or 33. And it actually can't be 33 because 33 has a divisor of 3, right? So you can actually rule out 3 and 33 from this valuable first step, okay? Now let's take a look at the second step, because this is the crux of the entire problem. Now notice that 12 is congruent to 1. Okay, 12 is congruent to 1 mod 11. We're checking 11 because 11 is the only thing left in our list, right? If this doesn't work out, then the answer would just be 1, okay? But this is 1. 15 is congruent to 4. Notice that 23 is congruent to 11 because 2 times 11 is 22, right? So that's why you have the 1 here. And similarly, we've seen that 34 is congruent to a 1 also. So that's how we get this, all right? But notice that this this is 11, okay? This part right here just equals to 11, okay? For all n. For all n. This is a much more powerful statement. For all, the upside down A means for all n, a member of the natural numbers. Or maybe the non-negatives, okay? Maybe the non-negatives. Let's see, does that work? I'm not sure. Okay, but anyway, we've completed our proof because this demonstrates without a doubt that 11 divides every single term, okay? Every single term. And these numbers, again, are super, super large. So that actually, 11 is congruent to 0 mod 11. That's trivial enough, isn't it? Okay, and so we're finished with the problem, folks. This is a QED. We know that the GCD, let's go back up here. The GCD of all of these terms right here, the GCD, and am I keeping it on the same screen here? The greatest common divisor. The greatest common divisor of all of those 2024 terms, the GCD is 11. I'm trying to get faster with this mouse, this trackpad on the Mac Air. Final answer, folks. Hope you enjoy.